of 0 to 1. X to the P, ln x dx. And they want me to find what values of P make that integral, what do they want? What am I doing? Find the values of P for which the interval converges. In other words, find out what gives me nice numbers there. No infinities, no minus infinities. They got any bright idea? Well, how about if we start off with this? How about if we say the limit as t goes to 0 from the right, integral t to 1, x to the p, ln x dx. Is that okay? All right, 0 to 1. Why is 0 giving us trouble here? Well, ln of 0 is minus infinity, isn't it? Mm-hmm. So now what? IBP. Integration by parts. Right, because we've got a polynomial times an ln. So here we're going to let u equal ln x, and we're going to let dv equal x to the p dx. So du, 1 over x dx, d, 1 over p plus 1 x to the p. I think we've just discovered a value of p that will not work. Yeah, well, if this actually turns out to be an integral that does us any good. So I can't write that yet, because who knows, maybe this didn't work. Maybe that won't even integrate form. And I'll have to go back and try something else. So, limit as t goes to 0 from the right. And we get u times v. So x to the p ln x over p plus 1. That's u times v minus the integral of v du, and that is 1 over x times x to the p times 1 over p plus 1 dx. Well, can I finish writing this first?
No. Isn't it xp plus 1?
Huh?
Isn't it xp plus 1 over?
Oh, thank you.
Yeah. Nice finish writing.
Now, thank you. 0 from, and the limits are t to 1.
You have to change the first one first.
Right?
You have to change the first one to p plus 1.
Oh, thank you.
Yeah, no problem.
All right, so limit as t goes to 0 from the right, and what do we have there? X to the p plus 1 ln x over p plus 1 minus the integral of 1 over p plus 1 x to the p dx. Oh, all evaluated t to 1. How am I doing so far? Now that I already made those other screw-ups, is this okay now? All right, so this is the limit as t goes to 0 from the right, x to the p plus 1 ln x all over p plus 1 minus 1 over p plus 1 quantity squared x to the p plus 1, all evaluated from t to 1.
Did you miss in p plus 1 on the left? The integral?
I got lost long ago.
Okay.
I'm not even here. I'm actually somewhere else in some mental playground. I don't know. Did I miss anything? Does that look okay? Okay, well, let's substitute in then. So this is the limit as t goes to 0 from the right. Plug in 1. And what am I replacing with the 1? X. So 0 minus. If I plug a 1 in here for x, I get 1 over p plus 1 quantity squared. Right? Now I'm going to subtract, plug in t. So what do I write? T to the p plus 1, ln t, over p plus 1, minus, and I've got, what do I have? T to the p plus 1 over p plus 1 squared. Fun problem, huh? Anybody got an idea what I'm going to do now?
Combine maybe?
Well, let's see. We can let t equal 0 here.
Why?
As t approaches 0.
As t approaches 0, this is just 0, isn't it? Question? All right, so let's go ahead and do that. This comes out in front of the limit because there's no t in it. Minus 1 p plus 1 quantity squared.
Everything else would be zero.
As we said, I can let t be 0 here. I get 0 in the numerator. So now I've got minus limit as t goes to 0 from the right, t to the p plus 1 ln t all over p plus 1. How am I doing so far? This is an awful lot of writing and easy to get confused here. So let's plug, is this right?
That's good.
Plug in 0. What do you get here? 0 times
Not 0.
Infinity.
infinity.
This is zero,
So that's an indeterminate form, isn't it?
L'Hopital.
El hospital. So minus 1 over p plus 1 quantity squared, minus 1 over p plus 1. I just thought I'd go ahead and get rid of the constant, right? Factor this constant out in front with the minus sign. Limit as t goes to 0 from the right, and we're looking at ln t over t to the minus p minus 1. Right, because t to the minus p minus 1 is equal to t to the plus p minus, t to the minus p minus 1 in the denominator is t to the p plus 1 in the numerator. Now if we plug in 0, what do we have here? Negative infinity, and what do I have here? 0, well, 0, do I really have 0 there? Yeah, I guess I do. What did I have over there? 0 times, oh, okay.
Did you lost L'Hopital's again?
Well, no, not yet. I haven't used L'Hopital's rule at all yet.
Oh,
So again, it's rather a misnomer. Let's see here. Here's one thing that we know. Forget that for a minute. I'm going to rewrite it. But before we write it, let's do some analysis on this. So as t goes to 0 from the right, I guess what we're looking for here, since this is an infinity on top, the only way that this has a chance of working is if we get an infinity on the bottom, right? So I think what the first thing we need is we have to say that this power needs to be something that will put this factor into the denominator. What would do that?
Negative sign?
Yes, maybe you could flesh that out a little bit. So you want p plus 1 to be what kind of number?
Negative.
Negative. Then you want p plus 1 to be negative? I'm thinking it through myself. I'm not just asking you, I'm trying to figure it out for myself as well. Here's why once again. Let's see, if we leave t in the numerator, we have 0 times infinity, which is an indeterminate form. So let me write this now like so. I think this will make it a little easier to see. Go back to red, it's easier to erase. Equals minus 1 over p plus 1 squared minus the limit as t goes to 0 from the right. And let's write this as ln t. Oh, and let me go ahead and factor out that 1 over p plus 1. So minus 1 over p plus 1. And now let's do the limit as t goes to 0 from the right. And I'm going to rewrite this in here as ln t over 1 over t to the p plus 1. I think that might make it a little more clear. So in order for this derivative to have a chance of existing, we need, well, we already know that we have an infinity on top, right? So in order to be able to do L'Hopital's rule and even having a chance for this to exist, I need an infinity on the bottom as well. So if t is equal to 0, is this 1 over 0?
Yeah.
Depends on what p is. What if p plus 1 is a negative exponent? Then that t is in the numerator, and when t goes to 0, I get a 0. Then I have infinity over 0, which is infinity. So in other words, at this point, I can say, well, we need p plus 1 to be 1 over 0 is infinity, right? So I need p plus 1 to be positive.
Positive.
So right now, I've got that condition. Even for this to have a chance, I have to have p greater than negative 1. So now that p is greater than negative 1, I know that indeed I have a 1 over t. This is a positive exponent. It stays 1 over t. When t goes to 0, I get infinity here and infinity there. That means I can now use L'Hopital's rule. So now we'll L'Hospital it. Minus 1 over p plus 1 quantity squared, minus 1 over p plus 1. And when we do L'Hopital's rule, we get the limit as t goes to 0 from the right. What about the numerator? 1 over t. The denominator, remember that that's really t to the minus p minus 1. When I do the derivative of that, what do I get? Minus p minus 1, t to the minus p minus 2, which is equal to minus 1 over p plus 1 quantity squared, minus 1 over plus 1 over p plus 1 quantity squared. I'm going to bring this minus out here. The two minuses become a plus. This is now a p plus 1 in the denominator. Combined with that p plus 1 in the denominator is a p plus 1 squared in the denominator, and I am left with a limit as t goes to 0 from the right, 1 over t on top, and I think, isn't that what I'm doing now? Yeah, I'm just rewriting this. And 1 over t to the p plus 2 on bottom. We're almost done, believe it or not. I think this one is probably a little more than what I could require of you on the exam, don't you?
I don't know where, but I checked out somewhere along this. I'm so lost. I can't catch up.
Don't worry, I got lost a long time ago either. I'm just sort of following my own work along step to step. So now I can rewrite this as the limit as t goes to 0 from the right. That's t to the p plus 2 on top, t to the 1 on bottom. So I'm going to subtract the exponents, aren't I?
Sure.
Yeah, I don't think I'll be putting this one on the exam. So when I subtract the exponents, so in order for this to exist, it has to stay in the numerator, doesn't it? If that exponent is negative, then I've got t in the denominator. As t goes to 0, I get infinity. So I need p plus 1 to be positive.
Again.
Which
Or is that p minus
greater
1?
than minus 1, which is what we found before. And now we know P should be bigger than -1.
Is that the answer? I can't tell.
I don't know, my eyes, if I can get them to uncross.